I love retro effects. This one is inspired by ASCII Art graphic design technique that generates images and videos pieced together from text. Let's learn about front-end web development, image processing, pixels and text. And let me show you step by step how to use Vanilla JavaScript and HTML canvas to create text-based visual art. We will write it completely from scratch, and I want to focus on clean code structure and good practices in object-oriented programming. I will follow encapsulation principles, and I will bundle properties and methods into a single independent unit, as if I was building my own animation library. There will be no global variables. Let's learn about private class methods. This video is a collaboration with my friend Evaristo, who refactored the code and helped me to choose the right coding practices to show you. He's currently working on a really cool animation library that uses multiple different pixel effects based on getImageData technique we will learn about today. Check it out, inspect his code, and maybe after watching this video and learning about encapsulation and pixel manipulation, you might even be able to fork his GitHub repository and contribute with some of your own improvements or even add more effects to it. I also have a set of other tutorials where I use the same pixel analysis technique we will learn about today to achieve different image manipulation and particle effects. I will link all of that in the video description. Let's take another step towards mastering front-end web development while building something cool and visual in the process. Hope you get a lot of value today. I create a basic web page markup. I link my style CSS file and JavaScript file. I create a div with a class of container which will help me to align my HTML elements. Inside we will have HTML5 canvas element with an ID of canvas1 and div with a class of controls. In there I create input element, type range, ID will be resolution, name resolution, minimum value 1, maximum value 20, and initial value, for example, 5. We will also need a label for this resolution input. ID will be a resolution label so that I can target it with CSS and JavaScript later, and text will say resolution 5 pixels for now. I will change the label dynamically based on a selected value with JavaScript. I will show you later. In style CSS I give body element black background. Container will have position absolute, border, top 50%, left 50%, transform translate -50% to center it. Canvas will have border just so that I can see where it is. Controls a div will also have a border. Input element will have width of 75%. If I give it border, we can't really see it. Label will have width of 25%, text color white, and font size 15 pixels. I give it some border so we can see how it sits there. Okay, I want to align input and label next to each other horizontally. The easy way to do that is to make their parent into a flex element like this. I remove border from label. I do a simple global reset to make sure we get the same layout in all browsers. In script.js, I start with canvas setup. I grab canvas element with getElementById and I save it in my custom variable I call, for example, canvas. CTX, shortcut for context, is this canvas variable from line 1 dot getContext2D. This video is about pixel array and manipulating images with code, so I create a constant variable called image1 and I set it to new image. This creates hidden img HTML element for me. I give it src property and here I set its source attribute. We have one challenge here. To achieve our effect, we need to use getImageData built-in canvas method to analyze image and scan it for pixel colors and coordinates, but this operation is restricted and it's only allowed under certain circumstances. Apparently, people can now hide malicious code in images, and when you analyze image data, you could expose yourself to that code. Browsers have built-in security measures to prevent that. It's called CORS, Cross-Origin Resource Sharing. To analyze image for pixel data, it needs to be stored on the same server or on a server with specific settings. I don't want to go deep into that topic today, so I will just tell you we have 3 easy options that I know of at the moment how we can achieve this effect with current CORS security measures in place. You can link URL of some online hosted images, but if that works depends on settings of the server you are linking your image from. You can Google search some images and try to link them. Some will work and some won't. If you decide to go with this option, you will also have to set cross-origin attribute on the image like this. Image.setAttribute cross-origin. It won't work for all images depending on setting of the server you are trying to link the image from. Some servers will give you error that says canvas was tainted by cross-origin data. The second option is to place your image in your project folder and to link it from there, but that won't work locally, only if you run it through a server. You can set up local Node.js server or even use plugin for VS Code editor called Live Server. If you run the code through your local server, it will be considered same origin and it will work. The third and the easiest option is to convert your image file into a base64 string. When we do that and include that image string inside our JavaScript file, it will be considered same origin and it will work with no issues. Let me show you how to do that. You can use built-in JavaScript toDataURL method, but today we will just use one of many websites that can quickly do that for us. I Google PNG to base64 and I choose this link. I will be using image 400 x 400 pixels and I drop it here. This simply just converts the image file into a long line of code, so we don't need that image file at all anymore. Make sure your string starts with data:image. If it doesn't, just click this checkbox. This will work with PNG and JPEG images, even though the website is called PNG to base64. JPEGs are fine. I copied this long line of code and I paste it here as a source for my JavaScript file. If you want to toggle word wrap in VS Code editor, you click View on the top panel and word wrap. It's a lot of code, so I will leave it on one line like this. Since we gave our image a source attribute, we can now listen for load event to make sure JavaScript runs only after the image has been fully loaded. On load, we'll run function I call, for example, initialize. I will scan image for width and height, and I set canvas width and canvas height to these values, like this. Let's check if it works and call ctxDrawImage. This is a built-in HTML5 canvas method that expects at least 3 arguments. Image we want to draw and x and y coordinates where on canvas we want to draw it. I pass it image1 variable from line 4 and I want the image to start from top left corner on canvas, so coordinates 0, 0. You can also pass it width and height, but it's not necessary in this case since we set canvas size to the same size as the image on lines 8 and 9. So this is how you convert image into a base64 data string, include it in your JavaScript file, and once it's been fully loaded, we can use drawImage method to actually display it on canvas. This is basic boilerplate code for many different pixel manipulation effects. Today, we will replace image with symbols to create ASCII art. To draw my effect, I will make it into a JavaScript class. I will give it some private properties, so-called private fields. These can only be accessed from within this class. By default, class fields are public. Private class members can be created by using a hash prefix like this. It is a built-in JavaScript feature, so privacy encapsulation of class features that start with a hash symbol will be enforced by JavaScript. You will get an error if you try to access them from the outside of your class. It will help us to keep the code modular and well organized. Let me show you. I will break image into a grid, analyze average color of each grid cell, and assign it a symbol based on the color. I will need an array that will hold all of these cell objects that make up the grid. I will call it, for example, image cell array. I will also create symbols array that will store a list of symbols we will use to replace pixels. I will show you. Pixels array will hold pixel data returned by getImageData built-in method. It will also need a reference to canvas, width, and height. Notice that all these private class members could have been declared as global variables, but since we want our class to be self-contained, independent, and reusable, we will not be using any global variables inside our class. As you may know, every JavaScript class has a special mandatory method called constructor. This method is called each time instance of the class is created by calling the new keyword. Constructor has only one simple job. When it's called by the new keyword, it will create one new blank JavaScript object and it will assign it properties and values based on the blueprint inside. So let's write that blueprint. My constructor will expect 3 arguments coming from the outside. CTX as a reference what canvas we want to be drawing on, width and height. Then I create a private class field called this#ctx and I set it equal to ctx passed here as an argument. I do the same for width and height. So when we call our constructor, we will have to pass it canvas we want to draw on and width and height of that canvas. With that information, our constructor will take these values and convert them into private class variables. I can also call methods directly from the constructor and they will be triggered when that constructor is called to create a new object. Let me show you what I mean. I create a private class member called this#ctx and I call built-in drawImage method from here like this. This syntax might look a bit strange for some of you. Let's see how it works. My goal here is basically to replace this drawImage call on line 10 where we wait for image to load and we call drawImage. Instead, I would like to wait for image to load on line 7 and then I want to create an instance of my ASCII effect class. And I want just the fact that I instantiated the class to draw the image. DrawImage is a built-in canvas method that takes 3 or 5 or 9 arguments depending on how much control we want over the image we are drawing. I will use the version with 5 arguments and I pass it image I want to draw, so image 1 from line 4. Starting coordinates are 0, 0. Width will be this.hashWidth variable from line 22 and height will be coming from line 23. It's good to test your code step by step to make sure everything works so far. This one is easy to test. Classes are not hoisted, so if I want my ASCII effect class to be available from my initialize function, I need to swap them around. Order is important. Remember that JavaScript reads your file line by line from top to bottom. So I comment out the draw image and instead I will draw that image by instantiating my ASCII effect class. First I create a variable that will hold my effect like this. Then I set this let variable to new ASCII effect. The new keyword is a special command in JavaScript and it will make JavaScript jump up to line 14 and constructor will run the blueprint and create one new ASCII effect object for me. On line 14 I can see that my constructor expects ctx, width and height to be coming from the outside as arguments, so I pass it ctx from line 2 as a reference to my canvas element. I pass it image1.width as width and image1.height as height. You can see as I create a new instance of ASCII effect class, it runs this line of code on line 18 automatically and it draws my image on canvas. I can delete the old drawImage method call now. I go back inside ASCII effect class constructor and I create a new private property called pixels. Again, I want this line to run automatically when I initialize my class and this time I want it to call getImageData method. GetImageData is a built-in HTML canvas method and it is the most important thing in this tutorial. It is the single thing you have to understand if you want to create animated pixel effects and if you want to be able to do image processing operations with the JavaScript and HTML canvas. So let's have a look at it and see how it works. GetImageData method simply takes 4 arguments, x, y, width and height, and it scans that portion of canvas and creates automatically generated object that contains some data about that scanned area. Most importantly, we needed to get x and y coordinates of each pixel that makes up the image and its colors. First I will show you the object that this method outputs, its structure, and how do we convert data in that object into a format we can use to create really cool web animations. Let's take it step by step to make sure we understand what's going on. This is the important part of the tutorial. I want to scan the entire canvas for pixel data, so I pass it 0, 0 as starting coordinates and width and height from lines 16 and 17. Again, as I said, this line of code is run automatically at the point when I instantiate my class with the new keyword on line 26. So at this point in my code base, we should have that pixel data returned by getImageData method available if everything went well. Let's check. Here on line 19 I create a property called pixels and I'm setting it equal to whatever getImageData returned after scanning the area I specified here. The new keyword will run this line of code so I can console log effect variable from line 22. I should be able to see all these properties here. Nice. And here we can see pixels array that is full of data about my image. So far so good. If I try to drill down into my object and console log pixels property directly, like this, I will get an error that says private fields pixels must be declared in an enclosing class. What if I try to console log it from inside my constructor like this? I change effect to this dot as I am inside my class. Yes, here we are calling getImageData and scanning the entire canvas area, and here we can see it returned something called ImageData object. This is an auto-generated object that getImageData method creates for us. It's very important that we understand what data it contains and how it's organized, so that we can extract X, Y, and color of each individual pixel. If I open ImageData object in console, there are three important things here we will need. It has height and width property, which is equal to the area of canvas we scanned. In our case, 400 times 400 pixels. It also has this data array. If I open that, I can see this data property is a massive array-like object with 640,000 elements. It is called UINT8 clamped array. That means it can only contain unassigned 8-bit integers, whole numbers with no decimal points, and it's clamped, which means the range of these numbers is limited. In this case, each one of these 640,000 elements can only be a whole number, integer, between 0 and 255. If I console log and drill down even further to display just this data array alone, I can search through it to see what does the data inside look like. As I said, this array can only contain numbers between 0 and 255, and each 4 elements in the array stand for color value of single pixel: red value, green value, blue value, and alpha opacity value. As you know from CSS RGBA declaration, you can achieve any color by combining different amounts of red, green, and blue. This is basically the same thing. The only difference is that alpha opacity is not a value between 0 and 1 like it is in CSS. Here it's a value between 0 and 255, so all of these are black pixels. 0 red, 0 green, 0 blue, and 255 alpha. We have a lot of black pixels in our image. If I search through the array, I will be able to find some other values here that make up other colors, not just black. If you need a proof that each pixel in the image is represented by 4 elements in the array, values for red, green, blue, and alpha, you can check it here. This array contains 640,000 elements. 640,000 divided by 4 is 160,000. We know that the image I'm using is 400 times 400 pixels. 400 times 400 is also 160,000, so that adds up. So we drew image on canvas from base64 data string, we analyzed it for pixel data, and now we have all pixel color values stored in this .hashPixels property on ASCII effect class. I need a way to cycle over the data, calculate X and Y coordinates of each pixel, and convert it to a symbol based on its original color. I will do it by creating a class method called scanImage. This method will be private, which means it can be only called from within my class, and it will be used only to transform the data within my class. My plan is to break canvas area into a grid. Size of individual fields in that grid will be decided by user. If each cell is 40 pixels by 40 pixels, since my canvas is 400 pixels wide, we will get a grid of 10 times 10 cells. If each cell is very small, for example 10 pixels, we will get a grid of 40 times 40 cells to make up our image. We will go even lower, all the way down to cells 2 times 2 pixels, and we will allow user to control the cell size. So my private scanImage class method will expect cell size as an argument coming from the outside. I will show you a bit later how we can pass it from the outside. So now let's create a grid of cells and organize our pixel data in it. The first thing I need to do, I will take image cell array from line 8 and I set it equal to an empty array. To create any form of grid in creative coding is easy with 2 nested for loops. The outer loop will cycle through rows. Rows go from top to bottom, so it will be Y vertical coordinate. Each time we enter new row, we will cycle from left to right, mapping horizontal X positions. Let's write it and then I will show you another visualization to make it even more clear how it works. So the outer for loop will cycle through rows. Rows come one under another, so this will represent vertical coordinates Y. We will cycle through the scanned image data through our pixels property from line 19, row by row, until we reach the bottom end of the image, so until pixels height. In our case, that's 400 pixels. Our image has 400 rows of pixels because it's 400 pixels high, but we won't be going through all the rows. We will be skipping rows based on resolution of the grid. So let's say I want a grid resolution to be 10 times 10 pixels per each cell. Every time I enter a new row, I increase y by cell size variable. Each time we enter a new row, we want to cycle through cells in that row horizontally from left to right. We want to cycle through horizontal x positions on that row. So x will start at coordinate 0 here on the left. As long as x is less than width of scanned area, we increase it, jumping by the amount of cell size. So this is how you cycle through a rectangular area in a grid. Outer for loop maps rows, vertical y coordinates. We enter this loop, and on the row with vertical coordinate 0, we enter this loop and we cycle through horizontal coordinates on that row, from left to right. When we reach width of the image, we exit the inner loop, enter the outer loop. Y will increase by cell size, so we will jump to the next row. We enter inner loop again and cycle through all horizontal x positions on that row again. We repeat this process row by row until we reach the bottom of the image, pixels height. So now we travel across the image in steps, mapping an imaginary grid over it. And these x and y values, coming from nested for loops, give us actual x and y coordinates of each individual cell that makes up the grid. We can do a lot of different effects now. What I will do, I will scan pixel color of each cell, average it out, and convert each cell into a different symbol based on the original colors in the image. This part is a bit tricky. I have a very long array with 640,000 elements, and they all come in one long line of data. Challenge here is to make sure we know what color values belong to which pixel position in the image. Since I know that each 4 elements in the array represent one pixel, specifically its red, green, blue and alpha values. Each value is an integer between 0 and 255. I also know that my image has width of 400 pixels and height of 400 pixels. This is all the information I need to be able to reach into this array every time I jump to a new grid cell in my image as I cycle through these nested for loops and pull out the correct corresponding coordinates that represent red, green, blue and alpha for that particular grid cell. Don't worry if you are struggling here a bit. This is hard to visualize, especially if you see it for the first time. Let's write the code and make it more obvious. I will need helper temporary variables. Position x will be x from the inner for loop times 4, because every 4 positions in pixel data array represent red, green, blue and alpha for one pixel color. I will also need position y, which will be y from the outer for loop times 4. We need to do this because we have image 400 pixels wide and 400 pixels tall. That is 400 times 400. Our image is made out of 160,000 pixels. But each of these pixels is represented by 4 elements in the array. So the pixels array has 160,000 times 4 elements, which is 640,000. I need a formula that will tell me that red color of pixels somewhere in this area in the middle is, for example, position 450,000 in this array. We need a single value that will take into account current vertical y position, current horizontal x position, and it will boil it down into a single index between 0 and 640,000 in this long data array. I'm skipping by 4 here because each single pixel is 4 positions in the array. First, I account for all the pixels from previous rows. My image is 400 pixels wide. Each pixel is represented by 4 values in this array. Each row is 400 times 4, 1600 elements in the array. So current position in the array is all the rows we have already gone through, so position y from line 27 times pixels width. Let's say I just finished cycling over row number 1. And I jumped to row number 2. I know red value of that pixel that starts second row in my image is position 1600, because one row has 1600 indexes in the pixel array, 400 times 4, and we count from 0. So by saying position y times width of pixels array, I'm saying take into account all complete rows we have already cycled over. In my case, knowing each row has 400 times 4 elements, plus add the current x position from the row we are currently on, plus position x. This part counts complete filled rows we have already completed. This part counts how far along are we along the row we are currently cycling over. This might be very hard to visualize and fully understand for beginners. If someone knows how to word it better, please leave a comment and let me know how to help beginners to explain this logic. It took me a while to visualize this the first time I saw it, so don't worry if you are struggling here a bit. Your ability to understand logic and math like this doesn't have much to do with your ability to be good with JavaScript. For now, believe me when I say that we are correctly mapping positions in pixels data array to our x and y coordinates. The hard part is behind us. Now I'm just gonna play with colors. First, I will check if pixel is not transparent. Position variable on line 28 is the first position in a set of 4 values within pixel array that combined represent red, green, blue and alpha of that particular pixel. So transparency is position plus 1, 2, 3. If alpha value that can range between 0 and 255 is at least 128, I will consider that pixel non-transparent and I will check its colors. Transparent or semi-transparent pixels will be ignored, which will save us some processing power with certain images. Now, I will just save pixels red, green and blue as temporary variables. Red will be current position index from line 28 inside pixel data array, so for the very first pixel in the image it will be this one here. Green will be index position plus 1 here, and blue is position plus 2, this one. Then we have alpha here, which is position plus 3, we have already used that, and then we have again red, green, blue and alpha of the next pixel and so on. Each time I create a new cell in my image grid, I will create a symbol based on average color value of this pixel. So temporary constant variable called average color value. First, let's get the total. Total is simply red plus green plus blue. Keep in mind, these are values between 0 and 255. Then I divide total by 3 and we get average. We will also save that color as RGB color declaration in case we want these symbols to retain original colors from the image. I simply concatenate RGB plus red from line 31 plus comma plus green plus comma plus blue from line 33 plus closing bracket. I want to assign each cell in our image grid a symbol based on average color value of the original image. For that, I will create a simple private class method I will call convertToSymbol. I will pass it average color value from line 35 as an argument. This method will have only one job: to take average color value and return different symbol based on that value. I declare it up here. I use hash symbol because this is a private class method, which means it can be called only from within this class. I'm passing it average color value as an argument. That will be represented as letter G, for example. It doesn't really matter. I just want something short. So if average color value we passed to it and called it G, if it is more than 250, return, for example, @ symbol. So very light white pixel areas in our image will have @. Else, if G is more than 220, return some other symbol. I will copy this line many times and I will go by 10 or 20 here. 240 is a star, 220 is a plus, 200 is hash, 180 ampersand, 160 percentage symbol, 140 underscore, 120 colon, 100 pound sign, or maybe $sign for Americans. These symbols can be anything, feel free to try different ones. The more breakpoints you make here, the more detailed your ASCII effect will be. It will be differentiating between different color ranges better the more breakpoints you give it. And therefore it will make it easier to see what image you are looking at once converted. I will show you. For example, here you can see that the first pixel has 0, 0, 0 for red, green and blue, so average color value, G, would be 0. Right, so we cycle through our image in a grid. We calculate index of each particular grid cell inside pixel data array. We check if that pixel is not transparent. We take red, green and blue value of that pixel. We use it to calculate average color, and we use that average color to assign each cell a different symbol. Every time we do this for each individual cell, we will push that data into image cell array, which will hold coordinates, color and symbol values for each cell that makes up our final effect. I will push it new cell and I pass it X, Y, symbol and color, values we just calculated. We haven't written this custom cell class yet. This one will be very simple. I don't need my black background to be replaced by symbols. I'd rather if it was empty, but that's just my decision. You can do whatever you want here. I say only create new cell if total from line 50 is more than 200. This will exclude very dark and dim colors. Keep in mind that total can be anything between 0 and 255 times 3, so between 0 and 765. I go up to line 7 and I will create custom cell class. Constructor will expect X, Y, symbol and color, since that's what I'm giving it here on line 60. This will be a very simple class. I will have draw method that will take ctx as an argument, so that we can specify which canvas we want to draw on. Fill style will be this.color from line 12. Fill text built-in canvas method will draw symbol from line 12 for us. We passed that symbol as an argument on line 8, and we created that symbol using custom convert to symbol method on line 35, using color values from the pixel array here. Fill text also wants X and Y coordinates here to draw it. We calculated these coordinates with our nested for loops earlier as we cycled through the image in a grid. So here I just pass it this.x from line 9, this.y from line 10. It was passed here as an argument coming from down here. These X and Y values are literally indexes from nested for loops. So that's it. Cell class is complete. On line 67 we are using this cell class to push each cell inside image cell array. Now I just need to put it all together and call it to run all this code and draw ASCII Art effect. My ASCII effect class starts on line 20. It has a lot of private properties and methods. I'm gonna give it one public method that can be called from the outside. It's called draw. Draw will simply trigger scan image private class method from line 51. I pass it cell size argument as it needs it to correctly travel around the image and create a grid. I also need to pass cell size to public draw method like this. I will check if everything works by console login image cell array from inside scan image method. To run my code, I need to call this draw method. Draw is a public method on ASCII effect class. Here I create effect variable, and here I'm setting effect to be an instance of ASCII effect class, which means it has access to its public draw method. And I call it like this. I take effect from line 81 and I call draw on it. I'm console logging image cell array here on line 71, and I can see it's coming up empty here. The reason is because on line 73 you can see it requires cell size argument. I will pass it, for example, 10. Each cell will be 10 times 10 pixels. Since our image is 400 times 400 pixels, we will get 40 times 40 cells. 40 times 40 is 1600. I get only 627 cell objects, because here on line 67 I ask JavaScript not to create cells for dark areas in my image. This is really good. I can see each cell has values for X and Y coordinates, symbol and color. If I make each cell 100 times 100 pixels, we will get only 6 objects with this particular image. You might be getting different amount of cells, since we are all using a different image with different amount of transparent and black areas. If I make cells very small, for example 2 times 2 pixels, we get a lot of them. Cell size affects resolution of the grid because of lines 53 and 54, where we jump by the amount of cell size every time we create a new cell data point. Cell size is being passed through draw method to scan image here. 30 times 30 cells give me 70 objects. 5 times 5 give me 2525 objects. You will be getting slightly different amounts. So each of my cells has color, symbol, X and Y properties. I will now cycle through my image cell array and draw them on canvas. I create another private class method on ASCII effect class. I'll call it, for example, drawASCII. First, I will call built-in clear rectangle method to clear canvas from old paint. Each of my cells has a draw method, here on line 14, that sets its fill style to color of the original image and draws a symbol there. On line 75, inside drawASCII method, I create a for loop. I will cycle through all elements inside image cell array, and I call their draw method. On line 14, I can see that draw method on cell class expects context as an argument to know which canvas we want to draw on. I will pass it this.ctx from line 28. Now I can call drawASCII private method from inside public draw method on ASCII effect class like this. Awesome, that worked. Well done if you watched all the way here. This effect is one of the more complex ones. I delete symbols array from line 22 since we are not using it. We are storing symbols inside cell class objects. I can change cell size here and it changes spacing between the symbols. We will improve this in a minute. First, let's connect the slider. Up here on line 7, I create a constant variable called input slider and I get it by ID. I gave it ID of resolution. I will also need to control input label. I give it ID of resolution label, like this. I take input slider and I add addEventListener for change event. When change event occurs, we will call custom handle slider function. I need to write that function. I will write it down here on line 89. If input slider value is 1, value of this attribute here that we initially set to 5. If it is set to 1, I want input label to say original image. And I will use built-in canvas draw image method to draw the original image. Else, I make the input label display the current cell size value, so resolution plus input slider value plus pixels, like this. Great, that works. I change width of input slider to 60% of its parent and label will be 35%, so there's enough space for text. Inside else statement on line 95, I will call draw method from line 82 to draw the final ASCII effect. Right now it has hard-coded cell size value of 5 pixels. I want to replace it with the current value of input slider. Like this, it won't work because value of slider is by default a string, which means it's number, but it's considered text as variable type. I need to convert it to integer. It's simple. I can just wrap it in built-in parse integer JavaScript method, which takes string and if possible it converts it to an integer, to a whole number with no decimal points. Perfect. Now when I move slider around, it works. Value 1 shows the original image. The other values change the size of cell grid. I replace effect.draw on line 103 with handle slider from line 89. That way it will run the code on the first page load as well. Sorry, I'm outside the screen. On line 103 I just call handle slider like this. By calling handle slider on initial page load, it will react to initial value attribute set in index.html here when the project first loads, before we start interacting with input slider. I can see we are not drawing all the symbols for all colors. Something is wrong. Let's fix it. The reason all symbols look the same must be somewhere inside convert to symbol method on line 38, since we are getting the correct colors from the original image, but they are not getting converted to symbols correctly. Oh yeah, it's because on all of these I'm using less than. It should be more than, the opposite. That's better. Awesome. We are converting average color values of original image into a set of symbols. I want font size of symbols that make up the effect to scale with cell size, with input slider value. So I do it here inside handle slider function. I use built-in canvas font property and I set it to the current slider value plus pixels Verdana, for example. I can tweak the font size by multiplying it times 2. Font size is delayed. It's taken value from the previous handle slider call. Why? Oh, I see. It's because the first I need to adjust canvas font property and then I need to draw my effect, like this. This is starting to look really good. It can be improved. The dark colored symbols blend with black canvas background, so they are not clearly visible. I could just set canvas shadow to white and give letters shadow highlights. This will work in most modern browsers, but in Firefox, currently it will cause very long processing time every time we change slider value and therefore our grid size, and it needs to recalculate and redraw the image. Firefox doesn't handle shadows well. I hope canvas shadows get better support in Firefox soon. Until then, we have a simple workaround to create fake shadows or highlights by simply drawing the same thing twice with slight offset. I can set fill style to white, I call fill text with 1 pixel offset, and then colored text will be drawn on top of it. Maybe it's too white now, how about 0.5 pixels offset? Doing this makes the dark edges of images clearly contrasting against the black background, so the overall shape of the image is clear and visible. I can play with the colors if I want to. I can color shift the image, or I can make it grayscale. I talk about these principles in my other Vanilla JavaScript pixel manipulation tutorials. Now that you know how to use built-in getImageData canvas method, maybe you can try to use it to create interactive particle effects, pixel rain, or constellation font effects. Check out video description for related pixel manipulation tutorials. I will see you there.